Hi, my name is Tiffany Collins and I am from the University of Adelaide. If you are unaware, HESJ 1825137 is the most powerful and luminous TeV gamma ray pulsar wind nebulae. This makes it an excellent laboratory to study particle transportation around pulsars. This presentation is a status report on modelling transportation of electrons from powering pulsar PSR 18261334. Just to give you an idea of what the system looks like, here is an antenna CO12 data in velocity range 40 to 60 kilometers per second. This corresponds to a distance of 3.5 to 4.5 kiloparsecs, with the pulsar being located at approximately 4 kiloparsecs. The Hess significant contours towards HESJ 1825137 can be seen in dark green, with the powering pulsar PSR 18261334 shown in pink. The red region describes the region towards neighbouring unidentified object HESJ 1826130. The HESJ 1825 equivalent Hawke and Lasso regions are shown in black and brown respectively. Both equivalent sources have recorded photons with energies above 100 TeV. Another interesting thing to note is that the equivalent sources are located between HESJ 1825 and HESJ 1826130. This poses interesting questions about the system. For example, how much is HESJ 1826 contaminated by HESJ 1825? And is HESJ 1825 and or HESJ 1826 a pevotron, where a pevotron is an object able to produce cosmic rays in the PeV energies? In an attempt to solve these questions, the region towards HESJ 1825 will be modelled with the pulsar as the source of electrons. Assuming a simple case of isotropic diffusion of high-energy electrons, the energy distribution can be described by this equation you can see on the right. The first term describes the diffusion of high-energy electrons in a particular region. The second term considers losses due to radiative processes such as inverse Compton, Bremsstrahlung, and synchrotron interactions. And the final term is simply a source term for particle injection. To numerically solve this, the region towards HESJ 1825137 will be split into a 3D grid of cells, which you can see to the left. The 3D grid will then be used to model the density, magnetic field, and soft photon fields, for example, towards HESJ 1825137. Each cell allows electrons to be transported in and out to neighbouring cells. After integrating the equation on the right over the age of the powering pulsar, the spectral energy distribution and radial profiles of HESJ 1825137 can be predicted, which is shown on this slide. The top left shows the X-ray radial profile towards HESJ 1825137 for photons with energies between 1 to 9 keV, while the top right shows the gamma ray radial profile with photon energies between 0.2 and 90 TeV. The predicted profiles are shown in black, which is then compared to the observed data as seen by Suzuki and Hess in red. The bottom left image and the bottom right image shows the predicted spectral energy distribution towards HESJ 1825 and HESJ 1826 respectively. As you can see, the model is able to predict the radial profile shapes of both the X-ray and gamma ray data, and also the spectral energy distribution of HESJ 1825137 is an approximate match, but further tuning of the model is needed to get an even better match. So thank you for listening to this short presentation. Please keep an ear out for further results. I'll leave you with this slide of my poster.